actually done. And before I give you a demo, I like to actually explain to you some important networking concepts related to port scanning and related to TCP/IP in general. Now on the screen, you can see what a typical TCP data packet looks like. So whenever TCP stands for Transmission Control Protocol, and I'm sure all of you have heard of the term TCP/IP. So TCP/IP, the TCP part is what I'm talking about now. This is what the TCP data packet looks like. And TCP data packet will have various fields. So you have a source port, destination port, sequence number, acknowledgement number, flags, checksum, options, padding, and then finally you have the actual data that is being transmitted. So whenever data is being transmitted using the TCP protocol, a data packet, something like this, is generated. Now I like all of you to focus on one field out of all the fields that have been displayed on the screen, and the field that I want all of you to focus on is the flags. What are flags and why are they so important? See, flags are basically, they represent the functionality of that data packet. Every data packet that is sent on the internet has a particular function that it has to perform or a particular significance. So depending on what flag has been enabled, a particular data packet may have a different significance or functionality. So I like to share with all of you a list of various TCP flags that are commonly used. Each TCP data packet has a particular purpose or function or significance which is specified with the help of the TCP flag option. A value of 1 usually means that that particular flag has been switched on. A value of 0 means that it is not on. In other words, every TCP data packet, there is a particular field called flags, and in that flag there could be various values which have been listed on the screen. You have the SYN flag, FIN flag, ACK flag, RST or reset flag, push flag, and urgent flag. So any of these flags could be enabled in a data packet, and depending upon which flag has been enabled in a data packet, the significance of that data packet or the purpose or the functionality of that data packet will change. So let me now share with you a list of various flags and their respective functionalities or purposes or significance. First of all, you have the SYN flag, the SYN flag or the SYN flag. The SYN flag is normally used to establish new connection. So whenever I want to establish a new connection with another machine, I will send that machine a SYN flag. Then you have a FIN flag, which means finish. So SYN means synchronize. So this is to start a new connection. FIN flag or finish flag means to end an existing connection. So when I want to start a new connection, I will send you a FIN flag. When I want to end an existing connection, I'll send you a finish flag. Then there is ACK flag. ACK stands for acknowledgement. Now acknowledgement flag is normally sent when, if you have sent me some data and I want to confirm to you or acknowledge to you that yes, I have received your data. That is what ACK flag means. And the final flag that I wanted to talk about is the reset flag. Reset flag means cancel a connection because of some error, or end a connection because of some error. So the difference between the reset flag and the fin flag is that if there has been no error and you just want to end the transmission or end the connection, then you send a fin flag. But if there has been an error and you want to just cancel the connection because of the error, then you send a reset flag. So as you can see, if I send a SYN packet to you, I want to start a new connection. If I send a fin packet to you, I want to finish a connection with you. If I send an ACK packet to you, I want to acknowledge that I've received your data. And finally, if I want to reset my connection or cancel my connection because of an error, I will send you a RST packet. So depending on what kind of packets I'm sending you, there is a different purpose or different significance of it. So now that you understand the various flags, let us actually better understand how connections get established on the internet and how connections are ended on the internet. So I'll introduce all of you to a brand new concept called three-way TCP/IP handshake connection establishment. So three-way TCP/IP handshake connection establishment. In other words, whenever a client means a computer, wants to establish a connection with a host, and a host means a server. So whenever a computer wants to establish a connection with a server, there are 3 steps that have to take place every single time. For example, if you're connecting to google.com, these 3 steps always take place between you and google.com. Or if you open your instant messenger or Google Talk chatting software, these 3 steps always take place between you and the Google Talk server. So no matter what you do on the internet, whenever any kind of connection has to be established between 2 computers, these 3 steps must take place. So what is step number 1? Step number 1 is that the client, which is basically your computer, sends a SYN packet to the server. And typically the SYN packet, like I had mentioned earlier, is to start a new connection. And essentially in step 1, what the client is saying, doing is that client is sending a SYN packet to the server, saying that, hi, my name is Ankit, I want to establish a connection with you. I want to send you some data. So next step, what happens is that when the server or the host receives the SYN packet from you, it will send back a SYN ACK packet. A SYN ACK packet is a packet where both the synchronize and the acknowledgement flags are turned on or enabled. So essentially, what the server is doing in step number 2 is that it is telling you that, hi Ankit, my name is whatever, Rahul. Nice to meet you. Even I want to establish a connection with you. And by the way, I acknowledge that I have received a SYN packet. So that is what happens in step number 2. Step number 3. The client now has to send an ACK packet to the host, saying that, oh, thank you so much, host. I have received your SYN packet as well, and now our connection has been established and we are ready to communicate with each other. So those are the 3 simple steps that have to take place each and every time whenever a connection gets established between 2 computers on network or on the internet. And these 3 steps are together known as three-way TCP/IP handshake connection establishment. Now imagine that after a connection has been established, you start transmitting data to the host or to the server, and after some time you want to end the connection. So how do you terminate the connection? What are the 2 steps that have to be performed? Step number 1, you have to send a fin packet or a finish packet to the host, saying that, thank you, it was very nice talking to you, but I need to go now, so let us end the connection. Once the server or the host receives the fin packet, in step number 2, it has to send back an ACK packet to you, saying that, thank you, I have received your finished packet, and hereby we agree to end the connection. Now please remember, for the connection to end properly, even the reverse needs to happen, where the host will also have to send a FIN packet to the client, and the client then has to send an ACK packet back to the host. So once these steps take place, then we can successfully say that an existing connection between the client and the host has come to an end. So now that you understand how a connection gets established on the internet and how it is getting terminated as well, how it gets terminated, I think now you understand the importance of flags. By just changing a flag in a particular data packet, the whole meaning, the whole purpose, the whole significance or the whole function of that data packet can be completely changed. So that is how important and significant TCP flags can be. So let us now discuss how you can actually send data packets with different flags switched on. So if I want to send you, say, a FIN packet, how do I do it? See, normally it happens automatically. If you just start your browser to connect to google.com, automatically your browser is going to send a SYN packet to Google. But what if you want to send some SYN packet to Google without using your browser? What do you need? So this is where you need to download a packet generation software or a packet generator like Colasoft Capsa Packet Builder. Colasoft Capsa Packet Builder. I'll just show you a screenshot. It looks something like this, and let me actually give you a demonstration of Colasoft Packet Builder as well. So if all of you look at the screen, this is what Colasoft Packet Builder looks like. It is basically a packet generator or a packet generation software. It allows you to generate your own data packets. It allows you to generate your own data. And the best part is, you have complete control over what kind of data you are creating. And you can change all the various fields of the TCP data packets that you are creating. So let's do this step by step. If I want to insert a new data packet, all I need to do is click on the insert button. On the left top corner of the screen, there is an insert button. So I click on the insert button. Then it is asking me to select what kind of data packet I want to send. So I want to create a TCP data packet. So I'm going to select TCP packet. And I'll click on OK. Now once I click on OK, that new TCP data packet gets added to this right hand side column. So now if you notice, the source and the destination is 00000. So I want to change all that. So I just select the data packet whose fields I want to change, and on the left hand side in this column I can change all the fields or all the values of that data packet. For example, there is something known as source IP address. So imagine if I want to send spoofed data packets, that is, if I want to send data packets from somebody else's IP address, then I can edit the source IP and I can type somebody else's IP address over here. So even though I am generating the data, it will seem like somebody else is sending the data. So that is the beauty of the source IP field. Next comes the destination IP. You need to specify whom you want to send the data. Right? So in the destination IP field, you can type the IP address of the computer to which you wish to send the spoofed data packets. Similarly, you can specify the source port number. So maybe you want to send data from a particular port on your machine, Actually, this software will not allow you to change the source port, but what you can change are the flags. So right now none of the flags have been switched on. So if you notice, you have the synchronize, reset, push, end of data, acknowledgement, urgent, and so on, right? So these are all the 6 important flags that we have mentioned earlier or discussed earlier. So if I want to send you a SYN packet, next to synchronize I just type 1, which means that it becomes a SYN packet. If I want to send you a SYN ACK packet, I can type SYN, I can type 1 in front of SYN and also 1 in front of ACK or acknowledgement. So now it becomes a SYN ACK packet, and so on. So that's how you can actually easily send spoof data packets, or you can modify the flag of a data packet and you can send data on the internet. Not only can you change the source IP of a data packet, you can also change the source MAC address. So imagine that you want to send data from somebody else's MAC address, you want to pretend to be somebody else, then this particular software, Colasoft Packet Builder, actually allows you to do that. Now when you're ready to send the data, just press the send all button, which is on the right hand side top corner of the screen, or kind of in the center top corner of the screen. So I select send all, and I can specify the options that I want, click on start, and the data packets get sent. So as you can clearly see, sending certain types of data with certain flags switched on is not very difficult. Name of the software is Colasoft Packet Builder. It's available as a free download on the internet. Along with that, there's another software which I like to recommend to all of you called Commodia Packet Crafter. Commodia Packet Crafter. Pretty much does the same thing. Allows you to change the TTL value as well, the initial TTL value. So imagine that you're a system administrator. You are running Windows, whose initial TTL value says 128, but you want to give the impression that you're running Unix, whose initial TTL value is 64. So what do you need to do to fool somebody else about which operating system you have? So you can easily do that by sending spoofed data packets using Commodia Packet Crafter, where you can change your TTL value, the initial TTL value, to anything else of your choice. So now that you understand what exactly are flags, you understand how connections get established on the internet, how connections are ended on the internet, and you understand the importance of port scanning as well. Let us now actually one by one understand and learn a variety of different port scanning techniques. So for each technique, I will explain the theory to you, and then I will explain the command that you got to type, the nmap command, and then I'll give you a live demonstration as well. So the first type of port scanning technique that I want to discuss with you is something known as the TCP Connect port scan. The TCP Connect port scan, it's one of the most accurate port scanning techniques available. It is very reliable, but at the same time it's easily detected. And there is no solution or countermeasure. In other words, there's no way to stop a criminal from performing TCP Connect port scan on your server at all. I mean, there's nothing that you can do to stop that from happening. So if you are a criminal, how can you perform TCP Connect port scan? So the command that you got to type, I'm just going to reduce the font size a little bit so it fits into one line. Alright, so the name of the first port scan is TCP Connect port scan, and the command that you got to type is nmap